Have you ever really stopped to think about the massive, kind of invisible machines that build our world? I'm talking about the cranes that raise skyscrapers, the lifts that fix our power lines, all the vehicles that move, well, everything. Today, we're going to pull back that curtain. We're going to look at the hidden world of heavy machinery and really get into the minds that dream this stuff up.
And that's the thing. Behind every single one of these incredibly powerful, complex machines, there's a person. It's not some faceless corporation or a factory, it's an engineer. Someone who looks at a colossal problem and thinks, yeah, I can build a machine to solve that.
So what does a mechanical design engineer actually do? Well, forget the dry textbook definitions for a minute. When you look at a portfolio like this one, it becomes super clear. These folks are the architects of physical force. They design the tools that let us, as humans, overcome the basic challenges of gravity and distance and just massive scale.
So let's start with the most fundamental challenge of all, and honestly, maybe the most impressive, just pure brute force lifting. How do you move things that just seem completely immovable?
This is the question, right? For so many industries, from construction to shipping, how do you get something that weighs tons and tons off the ground and put it exactly where it needs to go? And the answer isn't just one machine, it's a whole family of them.
And you see that right away here. It's not just about building one giant crane. The engineer's portfolio shows this whole toolkit of solutions for totally different problems. You've got a massive mobile crane for a huge construction site, sure. But you also have a much smaller, compact scissor lift for a car workshop. Each machine is a highly specialized tool, a totally unique answer for a very specific kind of impossible.
Okay, let's just pause on this number. 300 tons. That is the weight of a blue whale. It's like lifting 150 cars all at once, with a single machine that an engineer first sketched out on a computer screen. That's the mind-boggling scale we are talking about here.
But look, brute force is only one part of the story. Engineering also has to solve for height, for precision, and maybe most importantly, for getting people into these hard-to-reach places safely. And that's where the challenge gets way more complex.
Right? Just imagine you have to repair a power line way up high, or do maintenance on the side of a jumbo jet, or even just work on a high roof. Lifting a heavy box is one thing, but lifting a person and giving them a totally stable platform to work on way up in the air, that is a whole different ballgame for an engineer.
And here we go again, a whole range of super specialized solutions. You need to go straight up? There's a telescopic platform for that. Need to get up and around an obstacle? That's what an articulated platform is designed for. What if you're working near live power lines? Well, the design includes an insulated platform to keep workers safe. Every single one is a custom-built answer for a unique vertical challenge.
To put 42 meters into perspective, that's basically the height of a 14-story building. Just try to wrap your head around designing a machine that can not only reach that high, but can also give people a perfectly stable, safe platform to do their job. It's incredible.
And that's the crucial point. The real genius here isn't just in the height. It's in the machine's ability to bend, to pivot, and to hold perfectly still, giving a human a rock-solid foundation to work from dozens of meters off the ground.
Okay, so we've lifted massive weights, we've reached incredible heights, but that's still only part of the puzzle, right? Now we've got to move all this stuff around.
This is where we get into the world of logistics and transport. And, you guessed it, engineers don't do one-size-fits-all. The machine you designed to move a broken-down car is going to be completely different from the one you designed to move massive shipping containers.
This list just perfectly shows the sheer breadth of mobility challenges. You've got tow trucks for cars, huge dump trailers for raw materials, and then these super specialized dollies, things designed to navigate the controlled chaos you see at airports and shipping ports. Each design is dictated entirely by its job and its environment.
This is a fantastic comparison. Take the baggage dolly and the container dolly. They both move cargo, but they come from two completely different worlds of design. One has to be small, it has to be nimble to zip around a busy airport tarmac. The other has to be unbelievably robust to handle the insane weight of a shipping container. Same basic problem, right? Move stuff, but wildly different solutions.
And sometimes, the challenge of mobility isn't about raw power or efficiency. Sometimes it's about something more. Human. It's about dignity and safety and accessibility.
And that brings us to this, the Amulift. It's this incredible machine that combines a lifting mechanism with a transport vehicle for a very, very specific and important purpose, making sure that everyone, no matter their physical ability, can travel. It's this beautiful intersection of really complex engineering and, well, human compassion.
Okay, so let's zoom all the way out. We've seen machines that lift, machines that reach, and machines that move. But what does all of this add up to? How do these individual designs actually shape the world that we all live in?
And really, this is what it all builds to. Every single functioning piece of our modern world, from the airport you fly out of to the building you work in, it only exists because of a whole chain of these machines. They are the literal, physical connection between an idea on a computer screen and our shared reality.
Let's use the AmbuLift again, because it's a perfect example. Step 1, it starts as a blueprint, an idea. Step 2, that design becomes a real physical machine. And step 3, that machine fulfills a purpose that makes our world a better, more inclusive place. And this 3-step process, from blueprint to machine to purpose, it is happening all around us, all the time.
And that, right there, is the ultimate takeaway from all this. A portfolio like this isn't just some catalog of products. It's a record of solved problems. Every machine is a physical solution, a testament to human ingenuity, answering a very specific human need, whether that's building higher, moving faster, or just caring for each other.
So, the next time you see a construction site, or you're waiting at an airport, just take a second. Look for the machines we don't normally see. Think about the engineering mind that dreamt them up, and then ask yourself, what other invisible giants are out there right now, working hard to make my world possible?